In this video, we will be detailing the fundamentals of extrusion process, their types and their applications in the manufacturing process. The extrusion process. In extrusion, a cylindrical billet is allowed to force through a die in a manner which is similar to squeezing a toothpaste from a tube. A wide variety of solid or hollow cross sections may be produced by extrusion, which essentially are semi-finished parts. From the Latin word extruder, meaning to force out. A characteristic of extrusion is that large deformations can take place without fracture because the material is under high triaxial compression. Typical products made by extrusion are railing for sliding doors, window frames, tubing having various cross section, aluminum ladder frames, and numerous structural and architectural shapes. Commonly used extruded materials are aluminum, copper, steel, magnesium, and lead. There are three basic types of extrusion in most common process called direct or forward extrusion. A billet is placed in a chamber, which is a container, and forced through a die opening by hydraulically driven ram, which is also called the pressing stem or punch. The die opening may be round or it may have various shapes depending on the desired profile. An important feature of the extrusion process is that the grain flow of the material lies in the direction most suited to resist the applied stress during usage. Then the other types of extrusions are indirect, hydrostatic, and impact extrusion. Then the classification mainly includes hot extrusion and cold extrusion. Again, hot and cold extrusion is classified into forward and backward. The name implies in hot extrusion, the billet is heated to a temperature above the recrystallization temperature or at elevated temperature. Then, in cold extrusion, it is again divided into three: hydrostatic, extrusion forging, and impact. Both in hot and cold extrusion, the forward extrusion implies the extruded metal flows in the same direction as that of the movement of the ram, and hence the name forward extrusion. It is also called as direct extrusion. So in the case of backward extrusion, the extruded metal moves out in the opposite direction of the movement of the ram. This process is also known as indirect or reverse extrusion. Extrusion at room temperature or at temperature lower than the recrystallization temperature of the work material is known as cold extrusion. It is developed in the 1940s. The cold extrusion is a general form that denotes a combination of operations such as direct and indirect extrusion and forging. Cold extrusion is widely used for components in automobiles, motorcycles, bicycles, and appliances, and in transportation and in farm equipments. The magnitude of the stress on the tooling in cold extrusion, however, is very high, being on the order of the hardness of the workpiece material. Tooling design and the selection of appropriate tool and die materials are crucial to the success of cold extrusion. It is primarily used to produce parts in finished or nearly finished form. Cold extrusion has the following advantage over hot extrusion. They are improved mechanical properties resulting from work hardening, provided that the heat generated by plastic deformation and friction does not recrystallize the extruded metal. Good control of dimensional tolerance, reducing the need for subsequent machining or finishing operation. It has improved surface finish due partly to the absence of oxide film and provided that the lubricant is effective. Production rate and costs that are competitive with those of other methods of producing the same part, such as machining. Some machines are capable of producing more than 2000 parts per hour.
Hydrostatic extrusion. What is hydrostatic extrusion? It is a process in which the billet is completely circumscribed by a pressurized liquid in all the cases, with the exception being the case where the billet is in contact with the die. This process can be carried out in many ways, including warm, cold, or hot, but due to the stability of the used fluid, the temperature is limited. Hydrostatic extrusion has to be carried out in a completely sealed cylinder for containing the hydrostatic medium. The fluid may be pressurized in following two ways. Constant rate extrusion. In this, a ram or plunger is used for pressurizing the fluid in the container. Next is constant pressure extrusion. A pump with a pressure intensifier is used for pressurizing the fluid, which is then pumped into the container. What are the advantages? There is no friction amidst the container and billet. This minimizes the force requirements, allowing higher reduction ratios, faster speeds, and lower billet temperatures. Friction of the die can be largely reduced by a film of pressurized lubricant amidst the die surface and deforming metal. On applying high pressures, the ductility of material increases. There is an even flow of material. Next are the disadvantages. The billets have to be prepared by tapering one end so that it matches the die entry angle. This is essential for forming a seal at the starting of the cycle. Generally, the complete billet is required to be machined for the removal of surface defects. It can be difficult to contain the fluid under the effects of high pressures. In this 3 slides for hydrostatic extrusion, I have given 3 different figures. Now, the figures are the same, but depending on which suits or the figure which is more understandable can be used for understanding the hydrostatic extrusion. Thank you.
Impact extrusion. Impact extrusion is a manufacturing process similar to extrusion and drawing by which products are made with a metal slug. The slug is pressed at a high velocity with extreme force into a die or a mold by a punch. How impact extrusion works? To perform impact extrusion, manufacturing companies need either a mechanical or hydraulic press. The metal slug is positioned between a punch and a die. When activated, the press will move the punch down onto the metal slug, thereby forcing the metal slug through the die. The metal slug will then take the physical properties of the die. After the metal slug has been forced through the die, it's removed via an ejector. Advantages of impact extrusion. Although there are other extrusion processes available, impact extrusion has become a popular choice among manufacturing companies. For starters, it's considered a cold working process, meaning manufacturing companies don't need to heat the metal slug beforehand. The metal slug can be deformed at a near room temperature thanks to the superior power offered by the press machine. In conclusion, impact extrusion is a manufacturing related extrusion process that uses a press along with a punch and a die set to form metal slugs. It involves placing a metal slug between a punch and a die, followed by engaging the press so that it forces the metal slug through the die.
Hi, myself Rocky Zakaria would be discussing on the topic extrusion forging. As you all know, forging is the process in which a metal is deformed by applying a high compressive stress, and extrusion is the process of extruding this deformed metal through the die orifice. As you can see, the figure shows the tools used in extrusion forging. As you can see, the slug, also called as the billet, is the one in which the is the one that has to be deformed. The punch is the one which deforms the metal, and there's a small opening through which the deformed metal can be obtained. Let us now discuss about the principle or the working mechanism of extrusion forging. As you all know, extrusion forging is a mechanical process where the metal is deformed by applying a high pressure with the help of die and punch. The punch, also called ram, helps in deforming the metal by applying a high compressive stress and moves with a constant velocity, which helps in deforming the metal. The die is used in order to shape the metal in different shapes and sizes as per our desire. The die is designed in a manner so as to withstand the pressure and temperature of the heated billet. The billet takes the shape of die when high pressure is applied. It is also called backward extrusion process, since the product is obtained at the back of the die. Let us now discuss the merits of the extrusion forging mechanism. First of all, it's a low cost of operation, since it only involves less input and less number of tools involved for this production. Lots of tons of products can be produced. It is a continuous operation. A good surface finish of the product can be obtained by carefully setting the compressive stress and also the die that is needed. If the die is good, then also a good surface finish can also be obtained. And another important advantage of this process is that it's a fully automated mechanism, as all the inputs can be fed to a machine and the machine works accordingly. Next, we will be discussing about the limitations of extrusion forging mechanism. The first and foremost limitation is surface cracks or surface defects can be noted at the end product, and these surface defects or surface cracks are obtained due to the piling of higher residual stresses, which causes the crack, and these cracks can be prevented by carefully adjusting the value of compressive stress or reducing the value of compressive stress. Next, variation in the size of the material, and as the size of die that can be built is also a limiting factor, and product limitation is also another limitation, as only one type of section can be extruded at a time. And the last limitation is a high initial cost setup, as it involves electricity, and the making of this machines also is very costly.